Alright, Mr. Claxon's Algebra 2 students. We were trying to figure out today, the number one question for everyone that everyone was asking was whether or not we were going to have school tomorrow. And we've been exploring the Windchill index now for quite some time. I just wanted to take you through a few pieces of that just so you can make sure you are completing it correctly. For letter A, I wanted you to identify different conditions that would yield the same wind chill. So what are we looking at here? We're looking at the wind chill chart, and I've identified negative 17 degrees Fahrenheit here. When you have a 10-degree air temperature with a 50-mile-per-hour wind, it would create wind chill that feels like negative 17. Likewise, a temperature of 5 degrees with a 25-mile-per-hour wind would yield negative 17. And then we have to guesstimate here. If we're down to 0 degrees Fahrenheit, we're looking at about an 11-mile-an-hour wind. I would estimate, I could do some calculations there to figure that out. Would yield negative 17 degrees Fahrenheit. So that's really the only thing you have to do there. You do have to explain that or identify it, write it down. As far as investigating whether your school or district has policies regarding the school closure, I'm going to leave that up to you guys to kind of look at what caused a 2-hour delay the other day. You can go to weather.gov and look at a 3-day history. In weather.gov, you can put if you go to the website, you're going to see a big map of the United States. You can actually click on our area, and then you can click on New Philadelphia. To get that 3-day history and analyze some of that data, you click on the 3-day history right over here. And that will give you the date, the time at which it happened. By the way, this is military time, so notice how it just keeps going. It doesn't recycle back to 1. It goes to 13. So 13:53 is 1:53 p.m., 2:53 p.m., and then 15:53 would be 3:53. Okay, and you can run that back a few days to kind of see what created those conditions that caused a 2-hour delay. Fun to analyze the data. All right, but let's keep moving with the assignment. A major part of this assignment was that I wanted everyone here to graph and see the different graphs that can be created when we keep one of the variables constant. And before we got there, we did make some calculations. I wanted you to see this formula. What formula did I want you to see? The one at the bottom of the chart. This one right here. This is the formula that's used to calculate wind chill. Wind chill is what the National Weather Service uses. You'll hear about real feel and feels like from other weather companies. So looking down through here, how do we calculate? It is important that you should be able to make these calculations on a calculator like the one that's on your phone to make estimates. So, this slide and the slides that come later kind of explain how to do that. You can pause. Feel free to pause at any point if you want to study this a little more in depth. I do have the definition of a gust here. Sometimes you'll see a G. You'll see a G after one of the wind speeds, and that just means it's gusting up to that point. And that might factor into, will we have school? You might use that as an argument for not having school, because that will make the wind temperature, or that will make the wind chill feel colder. So looking at that, we kind of analyzed a few different temperatures here. This one right here that you're looking at comes from about 4 years ago. January 2014, it got really cold then. And school was canceled several times because of the cold. Okay, on to now the most complex part of this activity, which is where I wanted you to identify a constant wind chill. I gave you an example here on your chill out activity paper, and you see a graph here, and I'm going to just explain to you how to get this graph and what I want you to do, how to make this a constant. There's a simplified version and an unsimplified version. I show the simplified version, and then the simplified version down here, rather. The simplified version is in Y2, and that's where my simplified version will be. That's where you'll see it when I show you the simplified version for my own example. I'm giving you another example, so hopefully you can complete this on your own. And just how to get this window. This window will help you to draw the graph. Yes, I do actually want you to draw a graph by hand, as crazy as it might seem. Okay, so what was my example? Well, where are we going to have school tomorrow? Everyone's wondering, Looking at the temperatures, the current temperatures, not so current anymore, about an hour old, hour or two. When you left school, it was 13 degrees Fahrenheit. We had winds of 15 miles per hour, gusting to 20 miles per hour. So, it felt like -3 degrees Fahrenheit, and even a little bit colder with those wind gusts, which, we could go back and calculate, between which two wind chills that would be, but it is going to feel even a little colder than -3 degrees Fahrenheit. Looking at the forecast now, the forecast. We see that tonight, the low is actually supposed to go, it's projected to go as low as -2 degrees Fahrenheit, air temperature. Looking at winds of 11 to 14 miles per hour. It could be gusting as much as 25 miles per hour. It's going to feel really cold, really cold. And at what point will, could your skin suffer frostbite? Well, if you're out in the elements long enough, your skin can suffer frostbite. This chart right here is the one that Washington schools, or Massillon City schools, they used to explain, what they used to cancel school. Coming down to the difficult part of this assignment, I did want you, I just let my air temperature be -2. I would want you to let it be something else. What did I do here? Well, feel free to pause at any time. If I'm going too fast, just pause. That's a great thing about me being on video. Maybe one of the only good things about me on video is that you can pause it, take a look at it, and try to decipher what's happening here. So when I let my temperature be -2, I do need to let the wind speed be x. I know it was v up here, but to enter it into our calculator, we need it to be x. V might be, it might have another value assigned to v, so we're just going to let it be x in our calculator. You can see the unsimplified version, which I will enter into y1. That will be y1, and then how I simplify it here. All I did was multiplied and combined like terms. That's all I did. I simplified it down to this function, entered into our calculator. You'll see it as y sub 2 is equal to -36 605 thousandths times x raised to the 0.16 plus 34 and 497 thousandths. So I want you to make observations about the graph. I want you to plug in some different wind speeds there and see what happens. Then I want you to graph it. Well, let's go ahead and take a look at it. I've already entered it into my y equals. I entered in the unsimplified in y1 and the simplified in y2. You'll notice here that the unsimplified goes on for a long time. I have to keep clicking to the right. And what I've noticed is students can make mistakes whenever we have these long, drawn-out equations that we're entering into the equation editor. How do I know that these are both the same? Well, I could compare a table of them and make sure that they're getting equivalent values. So I know they're both the same. I'm going to go ahead and turn y1 off and just use my simplified version so as to not confuse the calculator. Now, if I go to graph it right now, my graph's really not going to communicate very well to me what's going on with this graph. You'll see that nothing is showing up here. In fact, the graph might even have froze, but I do need to try to, let's see, nothing is showing up, and the graph did freeze. So I'm going to go ahead and pause this video, try to fix the problem. Alright, due to the fact that I am experiencing technical difficulties here, I am going to have to just stop this right where I am. I hope that you were able to get something out of what you were supposed to do, what I intended you to do. I will have to post another video now and re-enter the equations back into it to show you how to get the window that you want and kind of what we're looking to get out of this activity. So sorry to break this up into 2 videos. You know,